Chapter 13.
Electricity and Circuits. We see many electrical devices such as air conditioners, refrigerators, electrical fans, electric bulbs, computers and televisions around us. These electrical devices need electricity to function. Thus, electricity has completely transformed our lives. Electricity is mainly used to run machines to make our tasks easier. Actually, electricity provides us with a form of energy called electrical energy. It is one of the most efficient, pollution-free and useful forms of energy. We cannot imagine our life without electricity. Activity 1. To find the source of electricity in an electric torch. Things needed: an electric torch, 2 new electrical cells. Method: take an electric torch and place 2 new electric cells in a certain order. Press the switch of the torch. We will notice that the bulb fixed to the torch lights up. Now, open the torch by unscrewing the opener from behind. Remove the cells and again press the switch. We will notice that the bulb does not light up. Conclusion: this shows that electricity is not produced in the torch when the cells are removed. This activity shows that the cells supply electric energy, electricity, to the bulb in the electric torch when the switch is pressed. Electric cell. We have learnt in activity 1 that in an electric torch, the electric cell is the source of electricity. The electric cells are a common source of electric energy for many purposes. Besides electric torch, electrical cells are used in transistors, radios, cassette players, electric clocks, battery-operated toys, calculators, wristwatches and remotes used in television, camera and video games. Electric bulb. An electric bulb or a torch bulb has an outer case made of glass that is fixed on a metallic base. With the help of a magnifying glass, let us look at what is inside the glass bulb. It consists of a tiny thin wire called a filament. The filament is fixed to thicker wires that also provide support to it, as shown in the figure. One of the thick wires is connected to the metal case at the side of the bulb. The other thick wire is connected to the metal tip at the center of the base of the bulb. The metal tip at the center of the base and the metal casing at its lower end act as terminals of the bulb. These 2 terminals of the bulb are fixed in such a way that they do not touch each other. When an electric current is passed through the filament of the bulb, the filament becomes white, hot, and gives out light. So the energy transformations taking place in an electric bulb are electrical energy, heat energy, light energy. Activity 2. To study the interior of an electric cell. Things needed: a discarded electric cell, a hacksaw, saw used for cutting metals. Method: observe an electric cell. There is a plus sign close to the top end of the cell and minus sign at the bottom of the cell. These signs stand for the positive and negative terminals of the cell. With the help of an adult, open the metallic counter of the cell using a hacksaw. We will see inside there is a blackish chemical paste. The chemical paste surrounds a carbon rod. The cell is sealed on top and covered with a cardboard case to prevent any leakage. Electric cells produce a small amount of electricity from the chemicals present in it. Once the chemicals are used up, the cell stops producing electricity. Activity 3. To light up a bulb with an electric cell. Things needed: 2 plastic-coated copper wires, an electrical cell, a bulb, insulated coated tape. Method: take two plastic-coated copper wires. With the help of an adult, remove the ends of each copper wire so as to expose the bare wire. Fix one end of an exposed copper wire with a plastic tape to the metal case at the side of the bulb. See position A in the figure. Another exposed copper wire is fixed to the metal tip at the center of the base of the bulb as shown position B in the figure, with the help of another plastic tape. Now, connect the other end of the first wire to the positive terminal of the electric cell by putting an insulating plastic tape as shown at position C in the figure. Similarly, we connect the other end of the second wire to the negative terminal of the electric cell by putting an insulating plastic tape as shown at position D in the figure. Observation. What do we observe? The bulb will glow. We find problem to hold the copper wires at a fixed place with insulating tape. We can use a bulb holder and can fix the bulb and the wires as shown in the figure.